Next is an online presentation by Zhujun, Xiao. Can you hear us?
Oh, yeah. Can you hear
All
me?
right, fantastic. We do. All right, so Zhujun, the floor is yours.
Should I start now?
Yes, please.
Okay. Hello, everyone. My name is Zhujun Xiao. I would like to present our research work on protecting users' online images against the unauthorized face edits. This work was done during my PhD study at the University of Chicago in collaboration with Microsoft Research. People love to view face photos, but also modify face photos. So today, there are numerous face editing tools, and they allow us to easily alter facial features, age appearances, and facial expressions. All can be done with just a few clicks. Many online photo platforms have incorporated such functions into their interfaces. The edits are so realistic that we cannot easily distinguish between original and edited images. However, face editing can also be misused, particularly by third parties. Consider the following example. User A decides to share her face photos on the internet. User B downloads one of these photos, uses face editing tools to alter its age. And then user B reposts the edited photo online to bully A. This is not a hypothetical situation, as many incidents of such nature have already been reported. So clearly, there is a pressing need for a tool that protects our uploaded images from unacceptable edits and reposts. This is the focus of our work. Note that our goal is not to prohibit all face edits, because healthy face edits enable effective interactions among users. Our goal is only to block those unacceptable ones to the targeted user. To do so, we must first know what types of face edits performed by the third party are unacceptable to users. To gain some insight on this decision, we first conducted an IRB-approved user study and obtained two key findings. First, users have different levels of acceptance or tolerance on face edit types. Second, they expect the tool to cover new face edit tools and types as they emerge. So this means that when we design the protection tool, we need the tool to offer personalized, user-specific protection. And the tool needs to seamlessly expand to new edited types and tools rather than just focusing on some limited ones. Based on these findings and their implications, we designed the tool as the photo moderation system, which can be deployed by image sharing services like Instagram. It performs two primary functions. First, when user uploads an original face image, the system collects the user's edit policy for this particular image, including face edit types that are acceptable to the user. Second, it performs as a gatekeeper by detecting and blocking any image upload requests that contains unacceptable edits based on the original image owner's policy. So images violating the user's defined boundaries are not posted to the platform. When designing this gatekeeper function, we ran into a very challenging problem. That is, given the photo upload request, how to detect the photo is edited and then recognize the specific edits. So previous methods try to detect artifacts left by specific face editing tools. However, these tools have significantly been improved, leaving behind minimal artifacts. Please see this example of aging results. At least for me, it's really hard to distinguish from edited one and original one. Furthermore, different tools produce very different styles when doing the same edit type. So this makes the detection even harder. So we need to explore alternative solutions. Indeed, detecting and recognizing edits directly from this single image itself is extremely hard. But what if we can locate the original image for each target image? If so, we can recognize the face edits by comparing the facial attributes between those two face images. So with this in mind, we designed a moderation system to include two functions. First, a file management function that for each image to be uploaded locates its original photo in the database. And second, a semantic analysis module that compares two images to identify modified facial features. Specifically, let's say we now have both the original and edited face photos. We can apply existing semantic attribute extractors, which are a set of pre-trained DNA classifiers, to identify the attributes of each face. And then, by comparing these attributes, we can identify the face edits included in the target image. Note that these extractors are modular, meaning when there are new edit types appear, we can easily expand the system to detect new attributes. Here is the overall system architecture. We named the system as Alicia, and it contains 4 modules. The 2 left side modules, Image Inspector and the Database of Original Images, define the file management function to identify and locate the original image for each incoming image upload. The next module, the Edit Recognizer, compares the original and edited image to determine the set of face edits. And the Policy Manager is in charge of interacting with the user to obtain the user's edit policy. We took significant efforts to design the first 3 components so that Alicia can meet the requirement of accuracy, scalability, and reliability. Please see the paper for the detailed description for each component. Next, let me illustrate how the system works in 2 scenarios. In scenario 1, user A takes a new photo of herself, here we call this photo X, and uploads X to a photo platform. This upload X will first be examined by the image inspector, which will decide whether the input image is an original or edited image. Here in this case, it's original. So the policy manager will interact with the user to let her define the edit policy, and then register the image together with its policy into the database. And the system will of course accept the upload request because the image is original. In scenario 2, user B downloads its image and changes the age of the face, now requesting to upload the edited image. Again, the image inspector will first detect whether the input image is edited or not, and here in this case is edited. So the image inspector will locate its original copy from the database together with the original image's policy. Both the original and edited images are fed into the edit recognizer to recognize the edit type. The edit recognizer will compare the edit type to the original image's policy to see if it's allowed by the policy. If it is allowed, the system will accept the upload. Otherwise, the system will either reject or flag this request to the original image's owner to review. So we evaluate Alicia using 2 groups of experiments. The first group of experiments focus on evaluating its accuracy, scalability, and reliability in terms of detecting image uploads containing unacceptable edits. In this part, we used both user studies and data-driven experiments. The second group of experiments seeks to understand how users perceive a protection tool like Alicia, and also to collect feedback on how to improve the tool. We will describe some key results next. Let's start from how we test the effectiveness. Here we use 3 different experiments. First, we tested on real users' policies and about 400 real user decisions which were collected by our first user study. And our system could detect the unacceptable edits with over 90% accuracy. We further built a large-scale face dataset with over 1 million face images, which include 12 edit types and 10 edit tools. And on this dataset, our system could achieve high detection and high recognition accuracy with low computation cost. Finally, we want to see how our system works on in the wild edits. So we recruited 8 volunteers and asked them to edit 100 face images as they wanted. And in the end, we collected over 400 freely edited images. Each of them include 1 to 4 different edits. And results also showed high detection accuracy and reasonable recognition accuracy. Finally, we conducted a second online survey to see how users perceive the protection tool offered by Alicia. For this, we recruit 100 participants, and we first walk them through our proposed system, and then ask each participant a series of multiple choice questions, and we even further ask them to explain their choices. Here, I will highlight one key result. When asked whether they feel their online images are protected with our system, 48% of them said yes. And 15% of participants were neutral because they think the system cannot guarantee 100% protection. On the other hand, we do notice that 37% of participants felt not protected by our system. After studying their explanations, we found that they carry a prevailing belief that sharing images online is always unsafe. This observation highlights the demand for a more trustworthy online environment for social interactions, and we believe the protection system like Alicia presents a concrete step towards fulfilling that need. To summarize, in this work, we propose a personalized face image protection system which can scale to new editing types and tools. Our evaluation with user studies and large-scale datasets showed that this system achieves high detection and recognition accuracy with low computation cost. As one of the first protection measures for third-party face editing, we also identified several limitations of Alicia and further directions, particularly on how to define and explain various types and levels of face edits to users, and also on how to get multiple photo sharing platforms to work together to provide global protection. Please see our paper for details.
Thank you so much,
That will be
Zhujun.
all. Yeah.
Thank you. Right on time. Thanks very much. All right. I've got a question actually online. While any of you would have any question, please raise your hand. So question online is, how did you select the attributes that you are checking?
Yeah, so we select the attributes that are commonly used for the by the popular face editing tools, but we do recognize that there are more. So we think because of this modular design, and it can be easily expanded.
All right. Thank you. Any other questions from the room? All good. All right. Thank you, Zhujun, again. Thank you.